Hey everyone, I'm Kelsey.
And I'm Reese.
And this is Charismatic Megafauna.
So tell me what you learned this week, Kelsey.
I learned about a study that was done in 2018, so last year, July of last year, that linked bird poop to the health of coral reefs.
Okay, I'm intrigued.
As you should be.
Yeah, they seem pretty unrelated.
You'd think so, but you'd be wrong.
Okay.
So this study was produced by Nicholas Graham, Sean Wilson, Peter Carr, Andrew Huey, Simon Jennings, and M. Aaron McNeil.
Sure, the usual suspects.
Right. I just like to give people credit when they do stuff like this because this is a lot of work. Yeah. It takes a lot to produce a scientific study and then write up the study and publish it.
Yeah, definitely.
I'm not leaving any of these people out.
No, good. I think that's a good thing.
Anyway, so they released this last year, like I said, in July. And they found that seabirds that feed on fish, which is a lot of seabirds.
Wait, what else would they feed on?
Well, I would presume that some could feed on vegetation. But like I said, I would imagine most, if not all of them, feed on fish.
Yeah.
They bring their waste. I'm talking about poop. They bring their waste back to the islands and deposit the nutrients from their fish poop waste onto these islands. So this increases flora and fauna productivity.
Sure. Fertilization, it makes sense.
Right. We use cow poop to grow crops. Islands use bird poop to grow whatever they're growing. Coconuts? I don't know.
Okay.
Stuff. They're growing stuff.
Yeah.
Now, I took that almost directly from the abstract of this paper. So I will link the Nature article in our blog post, which if you have been listening to us from the beginning and you've been looking for our citations in the blog posts and you haven't seen them, it's because Reese and I haven't put them in yet.
Yeah, they're not there, but they will be going up very soon.
Yes.
You have no reason to believe us when we say that, but it's true. We'll be putting them out.
They'll probably be up by the time you're listening to this episode.
Yeah, probably this week.
We mean to be people of our word, but sometimes we're not.
Yeah, we try.
Anyways, so like I said, I'm going to post this in the blog post. You might only be able to access the abstract, but the abstract has all of the worthwhile information in it. Anyways, they sought to answer the question of whether or not this effect, so the effect of birds bringing nitrogen-heavy wastes from fish in their poop back onto the islands. That's been proven that birds pooping makes islands more productive. We know that that happens.
Okay.
They wanted to see if this effect occurs on coral reefs that are close to these islands. Because presumably rainfall would wash any of the excess poop into the ocean and would cause there to be an excess of nitrogen.
Does the health of the island directly correspond to the health of the coral reef in general?
I don't know, but I don't think that the island exhibits signs of health because of the coral reef. Okay. I do think the coral reef is healthier if the nearby island is healthier.
Gotcha.
So like if it's a highly human populated island and those people are using a bunch of sunscreen, that can damage the coral.
Okay.
But I don't know how the coral reef being productive would affect the island nearby.
Yeah.
I could be wrong, and I'll look that up and put that in the next corrections episode if that's not true. But that's just sort of my impressions.
That would make sense. Yeah.
So the study that they produced, I read into it a little bit, and the way that they designed it was super cool. So they went to I think it's Chagos Archipelago, which is in the Indian Ocean, and it's south of the Maldives. Maldives?
I think it's Maldives.
I've always heard Maldives, but we're in the U.S., and I feel like we mispronounce so many things.
Yeah. Yet another item for the corrections episode.
Yep. Really what we're doing is just creating content for ourselves in the future.
Exactly. We know what we're doing. Or do we? I don't know.
I'm not sure we do. But this study design I found super interesting. In this Chagos archipelago, which is really isolated from other islands, There are some islands that have rats that have been introduced by humans, whether intentionally or unintentionally. And there are some islands that don't have rats. So they picked these islands to see if the presence of rats, which relates to the presence of birds, related to the health of the coral reefs.
So, like, the rats draw the birds there?
No, the opposite. And I'll get into that.
Oh.
So they examined these islands, and they found that islands that had rats had about 2.5 birds per hectare. I think a hectare
I was just going to ask.
is 100 acres.
I can Google it. A metric unit of square measure equal to 100 acres.
Nice. 100 acres in a hectare.
Yeah.
So on these islands, there were 2.5 birds per each hectare.
Okay.
Islands that had no rats had 1,243 birds per hectare.
How many was it for the first one again?
2.5 birds.
Holy cow.
That's an increase of over 600 times. Nope, that's bad math, but a lot. 500 times, we'll say.
Yeah.
Whatever 1,243 divided by 2.5 is.
That is nuts.
Oh, I have it right here. 760 times.
Check the notes, Kelsey.
I should be reading my notes, but I'm way too excited about this story.
Yeah. I feel like we're getting to the good part, too.
We are. That's why I keep getting more
I'm
and
sorry.
more excited.
I'm hanging you up.
So on islands without rats, there are 760 times more birds per hectare than on islands with rats. Now, a lot of these birds are sensitive birds. A lot of them are sensitive species because they're island species and they don't exist anywhere else. So some of the species that are on these islands are things like red-footed boobies and terns and all kinds of fun, beautiful birds, beautiful seabirds.
Yeah.
Now, on these islands, they looked at coral health near the islands as well, and they found that islands that had rats that were adjacent to coral reefs, those reefs were not healthy. Whereas islands that didn't have rats and had an abundance of birds, the nearby coral reefs were healthy. Now, they dove into this a little bit, and I'm not going to get super into it because I don't think it's that interesting to people who aren't super invested in this. But they looked at nitrogen deposition on these two islands and found that the nitrogen deposition on islands without rats was 251 times larger.
Yikes.
So there was 251 times more nitrogen deposition on islands that had birds but no rats.
That's just in the soil?
That's in the soil on the islands, yes.
Okay.
But in the coral reefs, they found that damselfish grew faster. I want to say the number was like 85% faster, but don't hold me to that because that could just be a number I made up.
Yeah. 89% of all statistics are made up.
Yeah.
Yeah.
Like the one Reese just made up.
No, I read that somewhere.
I think I saw it somewhere.
Yeah.
So the damselfish are growing faster, and coral-eating fish like parrotfish thrived. They kept the coral clean, and they cleared dead coral. So the coral reefs that were adjacent to islands that had a bunch of birds on them were vastly more healthy. So before we wrap up this topic, I want to talk a little bit about why rats are bad on islands. So you might be wondering why an abundance of rats means that there aren't very many birds. And it's because rats love to eat eggs. Most shorebirds, most seabirds that nest on islands are going to be nesting on the ground because there aren't natural predators for them there.
Okay.
So because they're nesting on the ground and Europeans in their infinite wisdom introduced rats onto these islands, the rats can run around and basically eat all of the eggs they can find.
This is kind of a stupid question. Can rats swim?
Yeah.
Okay. No, I have a new nightmare, I guess.
Rats are great. I love rats.
Not if you're a seabird, but...
They're super social. They're super sweet, but they do not belong anywhere that is not someplace that they're naturally found. Now, that can be proven by looking at rats in any island situation across the world because rats have been introduced in a lot of places, and a lot of islands have struggled to keep rat populations down. So there's a lot of work being done right now to ensure that rats are removed from certain islands. I want to say over 500 islands have tried to get rid of their rats, and in a lot of cases they can be pretty successful. But it's been demonstrated in a lot of studies that the abundance of rats on islands is closely tied to the decimation of species on those islands. The biodiversity goes down. The coral reef health apparently also goes down, which means these cute little social beings are causing a bunch of havoc.
Is there any island that rats are native to?
The UK?
I knew you were going to say that.
I mean, the UK is an island.
Yeah. Yeah, fair. Anything a little more remote?
I don't believe so. So the scientific name for rats is Rattus norvivorus. I can't remember the species name.
That doesn't sound right.
It's close to that.
Is it?
It is, yeah.
None of them sound right to me.
No.
They all sound like, well, made-up words.
Well, you're not super far off on that.
Yeah.
But they came from Europe to the U.S., and they went from Europe all over the world. So I don't know where they're endemic to. I don't know where they are supposed to be, but I can tell you that there are a bunch of places they aren't supposed to be.
Yeah. Okay.
But that pretty much wraps up bird poop and coral and rats.
Crazy.
Yeah.
So what it sounds like you're telling me is that everything is connected
Essentially.
in the circle of life.
So that actually leads us really well into our main topic for today, the circle of life, everything being connected.
Yes.
What we're going to talk about today is a relatively new coined term, but it comes from a very old place. So we're going to call it One Health, but it has existed in many forms throughout history. Most notably, it looks like the oldest concept, the oldest time this concept was written down, was when Hippocrates wrote about it, like 500 BC or AD, whenever he was around. But he said that the health and clean environment are very closely tied together. So if people are in a clean environment, they tend to be healthy. If people are in a dirty environment, they tend to not be healthy.
It makes sense. How did people react to that theory when he said it?
I mean, he was a famous physician, so
Okay.
I think it was fine. But germ theory didn't come along until not too long ago. Late 1800s, early 1900s maybe?
Yeah.
I'm pulling that out of the back of my brain, so that could be completely wrong. But the idea that surgeons should wash their hands between patients or before sticking their hand inside of a body is a relatively new idea.
Yeah. Well, I feel like it's sort of the mentality that gave us bloodletting and
Right.
leeches and stuff.
Maybe not too concerned about sanitation.
No, I wouldn't think so.
So One Health, the definition is basically that it is meant to be a collaborative effort of multiple disciplines, working locally, nationally, and globally, to attain optimal health for people, animals, and the environment. That is the definition as given by the AVMA, or the American Veterinary Medical Association.
Okay.
And they've sort of spearheaded this, kind of. It's been spearheaded by a couple of different organizations who have banded together to be collaborative, which is great. Like I said, it's a multidisciplined approach, and it's meant to help solve these global health problems and environmental health problems that we're seeing right now. And this focus on collaboration is a pretty big 180 from what we've seen in a lot of industries in the past. I always think about the FBI and the CIA, or the FBI and local police forces, who don't want to work together. So some of them will collect some evidence, some of them will collect other evidence, and instead of coming together and reviewing all of the evidence at once, they will keep their secret pieces of evidence from the other group, and crimes go unsolved.
And then that's what gives us those TV arguments about jurisdiction.
Right. And they have been getting a lot better as well. But this sort of has occurred in the medical community and the veterinary community for a long time, that we don't really want to share. We're not working together. People who are making huge breakthroughs in human medicine don't always apply that to animal medicine. Mm-hmm. But since this approach has really been instituted, we're seeing that change a lot, which I think is great.
Yeah.
Just bang up job, guys.
So how has that been implemented, I guess?
We'll get into that.
Okay.
Because it's in multiple ways, but it isn't as if there is a big One Health organization that says we're going to do this, 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 and this.
Okay.
There is a One Health nonprofit that is working to spread this idea and create this collaborative environment. But in terms of it being instituted, it's being instituted by individuals.
Okay. It's more of like a philosophy.
Right.
Sort of. Okay.
Right.
Cool.
This has been really important with regards to the control of infectious diseases, which is something that I've always found really interesting. And maybe I'm alone in that. But infectious disease and how it spreads is bizarre in a lot of ways. And I think an understanding of the environment that it's spreading through and possibly non-human hosts is super important to battling widespread infectious disease outbreaks.
Yeah, I think that's probably a pretty important topic right now.
Right. So what I have here is just a little bit of information. The Institute of Medicine put out a piece of literature in 2003 suggesting that we are potentially on the verge of a perfect microbial storm, which is horrifying.
It sounds horrifying, but I don't know what it means.
So it's essentially meaning that we are on the cusp of huge outbreaks, huge disease outbreaks. And this is linked to a couple of things. I'm not going to run through their whole list. I'll link their report. But it's linked to global travel, increased host susceptibility, land use changes, human-animal infrastructure changes and breakdowns, poverty, and social inequity. So I'm going to break each of those down, and we can talk about all of them individually. I just wanted to get the whole list out there. So we are at a time where global travel and transportation is the easiest it's ever been. But that also means that a lot of people are spreading all kinds of nasty stuff around the world.
Like rats.
Like rats. This is the modern day version of people bringing rats around the world.
Yikes.
I looked it up in the break, and it turns out that Rattus norvegicus, which is the actual scientific name, it's also called the Norway rat, actually came from somewhere in Asia, likely China. So these rats, very prolific, very good at spreading around the world.
Yeah.
Happy for them if they weren't destroying us.
Why are you happy for them?
Because they're successful. I just love seeing success in all forms besides billionaires who keep all their money to themselves. But we're not going to go into that today.
That's probably wise. You're rooting for the underdog.
I like the underdog, which means I probably shouldn't like rats.
Yeah. Are they're not the underdog?
Rats are so successful.
Okay.
This is, again, not related to the topic today.
No.
But rats, or rather the mammalian family that has rats in it, so rodents, make up 50% of the biological diversity of mammals.
Get out of here. Of mammals.
Of mammals.
Okay.
Not of everything.
That's still pretty bananas, though.
But that's a lot.
Yikes.
That isn't all rats. But in general, rodents are pretty good at surviving.
Yeah. Okay.
So maybe I shouldn't be rooting for them. I personally think that rats are just so cute.
Yeah.
They like to be tickled. So if you're having a bad day, go to YouTube and search rats being tickled because they love it. But yes, they decimate human populations by bringing disease. Things like the bubonic plague probably came by rat.
Yeah.
So in general, not the best for human health.
Yeah. They're a complex sort of anti-hero.
Right.
Yeah.
Right.
Okay.
But like I said, we are basically the rats of the 21st century because humans are carrying diseases across the world. Not great.
No.
Now, the second thing on the list is host susceptibility. So this ties into global things where we can now travel to places and spread disease to hosts that would have never been exposed to these diseases. So there is a lot of contention over things like missions trips, where people go to certain relatively remote areas in the jungle to touch base with tribes and try and spread their gospel, whatever it may be. And this can be really dangerous for those tribes because a lot of us have been vaccinated against all of these diseases. So it's possible that we might unwittingly carry these diseases into this tribe and kill all those people.
Yikes.
Even things as simple as the flu. Because we interact with so many people, have developed a relative ability to not die from the flu unless we're immunocompromised. But in other parts of the world, that's not true. So there's a lot of concerns over the host susceptibility, over traveling to places where they're not exposed to the same diseases that we have been, and they're also not vaccinated.
I feel like this is fueling maybe anti-vaxxers.
We're going to touch on that, actually.
Oh, really?
Yes.
I can't wait.
We're not going to go super deep into it, but we are going to talk about vaccinations. I have some feelings.
Good.
So next, we're talking about land use changes. This just means humans are spreading across the landscape and they're changing it from its natural form into another form. So that would be cutting down forests to plant trees, or not plant trees, to plant crops, or cutting down forests to graze your cattle, or cutting down and draining wetlands to expand city areas because we're becoming more urbanized. As we continue to have more children, the world becomes more populated and we need places to put those children. Those kinds of things have been closely linked to disease outbreaks because now we're all close together, which isn't good. But also we're destroying the environment, and that environment was capable of holding a lot of ecosystem services. And when the environment dies because we've killed it, that's closely linked to animals getting more sick and, by extension, humans getting sick.
Didn't you kind of talk about the habitat fragmentation a little bit last time? Is that a part of this too? It sounds like it.
Absolutely.
Okay.
Yeah. So the hope is that I can sort of weave a level of understanding throughout all of these podcasts where I'm talking about issues that affect habitat use or that affect disease spread, because that is sort of where my interests lie. So because of that, I think we're going to talk a lot about it. But it's also important because it's tied into almost everything we do. This is a doom and gloom podcast today.
Yeah, I'm feeling good. Mine is a pretty light subject. Good. Pardon the pun.
Reese is going to raise us up at the end of this.
Yeah.
Human and animal infrastructure breakdown is I think more tied to the fact that humans and animals are coming into close contact more than they used to.
Okay.
Especially as we move towards countries that eat a lot more meat, and there needs to be meat production to meet that demand. Animals are put in smaller cages and are kept in buildings where they never see the sunlight. They're never getting airflow through there, and that is a hotbed for disease.
I'm sure.
The last couple of things I mentioned are poverty and social inequity, which these two things are a big issue for disease, because if you live in a state of poverty, it's likely that you aren't going to have access to the medical care that you need if you do get sick.
Yeah.
It's also likely that if you get sick, you're not able to take off time from work. So you have to go to work and you're sick and you're spreading that sickness to other people at work, and you aren't really given the option, which is horrible and is a pretty horrible part of our current society that I hope we can change throughout our lifetimes.
Yeah.
And that ties in, like I said, to social inequity as well, where the poor are getting poorer and the rich are getting richer. But that's all super interesting to think about because the idea of One Health is that the environment, the people, and the animals are all connected. But as you can tell, it's also socioeconomic statuses that are connected and our choices to eat more protein that play into this, and things like buildings and how we're implementing infrastructure and things like that, where those are things you wouldn't think about affecting disease transmission and affecting ecosystem or human health. But we're starting to see that they are really closely tied together.
Well, I think if you have a very narrow range of focus and you're only really thinking about your self-interest or, something a really specific goal, then you're not going to want to consider other factors because they might affect that. Whereas if you have more of a universal, wide view, then you may be more understanding.
Yeah. Yeah. I think that's very true.
Yeah.
And that brings me into sort of this anti-vax movement that we're in right now.
Tell me about it.
You see people in first world countries or developed nations deciding not to vaccinate their children because we haven't had issues with things like measles in a long time. But because these people aren't vaccinating their children are becoming carriers for these diseases. There was just that huge measles outbreak, and they tied it to a person who decided not to vaccinate his child. And he said, well, I don't want to call myself anti-vaccination because that's not what it is. I just don't want a child with autism, which says something, because if you would rather have a child die of measles or some other horrible disease that you can vaccinate against instead of having a child with autism, you need to do some serious self-evaluation, because autism is not a horrible thing.
Compared to death? No, I wouldn't think so.
Yeah, a dead child is the worst.
Yeah.
That's the worst option. And you're putting your children and other children who are immunocompromised at risk.
Have they even proven that it's connected?
No, it's based on a study. Maybe we should do a whole episode on this. It's based on a study from the 90s produced by one doctor that was so medically inaccurate, he lost his license to practice medicine. So there was one study that said one compound in vaccines can cause autism. There are thousands of studies that have proven there is no link between vaccines and autism. So I don't mean to get super lectury on anybody, but I just encourage you to trust the doctors who have done a lot of research and they know what they're talking about. And this anti-vax movement has now been tied to a lot of these outbreaks. And you have to wonder, if we continue on this path, we are going to undo hundreds of years of medical advancement, and a lot of people are going to die. Yeah. Like I said, we are the rats of the 21st century.
Yeah.
We are killing people unintentionally by carrying microbes across the world.
Yikes.
Now we're going to get into even the scarier parts of the One Health movement.
Oh, good. The light and fluffy part is over.
The light and fluffy part is done. You got your lecture about not vaccinating your children. Now you get to hear about AIDS and mad cow disease. So the emergence of HIV and AIDS and the emergence of bovine spongiform encephalopathy, which is mad cow disease,
yes,
will henceforth be referred to as mad cow disease.
Cool.
These all are due to the existence of the One Health concept. HIV and AIDS was a non-human primate disease that made the jump into humans and has decimated populations in Africa. It was decimating populations of disenfranchised groups in the United States. And we are just starting to get a handle on it, or we have been for like a decade now, which is great. But that doesn't negate the fact that it did jump from animals to humans, and that is the same with mad cow disease. The human variant of mad cow disease is Creutzfeldt-Jacobs disease.
Yeah.
Which I tried to tell Reese about in the past, and I thought it was Jacob Kreitzman's disease.
Yeah, that's what I was going to ask.
So I apologize to anybody named Jacob Kreitzman.
Yep. You had nothing to do with this.
No. Creutzfeldt-Jacobs disease is a disease that basically is existent because of prions. So prions are things in the brain that can cause degeneration. We're not going to go super far into it because I haven't done research on this part of it, and I don't want to make something up. But essentially, it is a disease that affects the brain, and it can cause all kinds of horrible things. So with mad cows, it's called mad cow disease because they essentially went crazy, and something very similar happens to humans when they get it. It's pretty rare in humans. No. I'm gonna amend that. It's incredibly rare in humans.
Yeah.
So don't worry about it. And most of the people who get it because they ate infected cow, which we have made some steps to ensure that that does not happen.
Okay.
So we have altered the beef industry to ensure that mad cow disease does not spread into the human population.
Okay.
However, I would caution that the best thing a disease can do is mutate. Diseases are very good at changing and becoming even more virulent or able to be spread and able to affect more hosts.
Yeah, sort of their function.
Yeah, it's their MO.
Yeah.
Is how many things can I infect?
Yeah.
So while we have things under control now, it is possible that we may have issues with these kinds of things in the future. Something that is not based on human health is an amphibian disease. It's a fungal disease that is decimating populations of amphibians. It's called chytridiomycosis, which is just a fancy way of saying a fungal disease.
Okay.
And it threatens the biodiversity of everything around it in its ecosystem. So amphibians can be really important in ecosystems, and they can also be really hard to manage and help recover if they're being decimated. And with chytridiomycosis, we aren't super sure of how to help the frogs, is my understanding, how to help them on a larger scale within the environment, not how to help individual frogs. So because we're seeing this decimation across a bunch of different types of amphibians around the world, we're concerned about the effect that that might have on the forests and environments that they live in and how that might affect human health. Now, the last doom and gloom that I want to talk about before we sort of turn this ship around, we talk a little bit more lightly, we focus on the positives to end it off, is microbes cause the death of millions of people every year in the form of food and waterborne illnesses.
Okay.
So that is a really unfortunate way that animals, the environment, and humans all come together to cause something horrible.
What is that like a bacterial infection?
It can be. Essentially, all I mean by that is that some sort of bacteria or microbe, which is just a small, like single or multi-celled organism, like small multi-celled organisms, get into water sources and they get into food sources and they cause diarrhea.
Fun.
Yes. Just everything. That's the way I want to spend my Saturday evenings. But it causes such severe diarrhea that it's killing millions of children around the world every year.
That's rough.
Right.
That's some rough diarrhea.
Yes. And it's one of those things that access to clean water is something you hear a lot about, and it can be hard to understand why certain water sources can't be used.
Is that like why Americans aren't supposed to drink water in Mexico?
Yeah, partially. But it's a huge thing is we have access in the U.S. for the most part, not counting certain cities that are still struggling with things like lead poisoning. In general, we have access to pretty safe water, more so than developing countries, but less so than other developed countries. There are a lot of developed nations that have better water than we do.
Yeah.
But in general, we don't have to worry about our water killing us, whereas that is something that you do have to worry about in other parts of the world.
Sure.
Because it's a reality for a lot of those people.
And this is why.
Yeah. It's
Okay.
because of the microbes that are living in the water or that get into the food sources and cause GI upset. And then you can't recover because you lose so much of your water.
That sounds like just such a bad way to go.
Yeah, I mean, it sounds like the worst way to go.
Yeah.
Okay. So if you've stuck with us for this long, thank you. Sorry to turn doom and gloom on you.
Is there a light at the end of the tunnel?
We're turning this around.
Oh, thank God.
So the One Health idea is now recognized by many organizations around the world. Places across Asia and Europe and the US, even organizations in Australia and New Zealand. This is reaching everywhere. Now, the first step to solving a problem is understanding the problem. So by all of these organizations recognizing that this is something we need to be concerned about, and by recognizing that destroying the environment leads to a lot of other problems that aren't necessarily implicit, is huge. I'll give you just a couple of examples. The CDC created the Center for Zoonotic Vector-Borne and Enteric Diseases, which is a huge win, I would call it, because it shows that the CDC is now accepting, the Center for Disease Control is accepting that zoonotic diseases, vector-borne diseases, and enteric diseases are a huge problem. And these things come from environmental factors. They come from animals. They come from the environments we're living in.
Okay.
So by creating that division, they are preparing themselves to deal with these outbreaks. They're preparing themselves and doing the research and learning what they can to stop these outbreaks before they become a big problem.
Gotcha. So it makes them, they're just being a little more proactive about it.
Right.
That's good.
It's wonderful. The EPA is doing the same thing. They have the environmental health focus, and they've decided to tie environmental health to animal health to human health. So the EPA is the Environmental Protection Act, or agency, not act.
Yeah.
So their focus is the environment, but they're beginning to branch out and sort of tie that into how protecting all of these things at once creates a more productive environment, creates healthier humans, creates healthier animals, and the connections between them stay good.
Sure.
The last thing I want to leave us on is probably the most interesting part that I learned from researching this, because One Health is a thing that I've always been really interested in, and I would love to focus future research on as I go into graduate school and do graduate work. I think that acknowledging this is super important, and I think we're on the cusp of it expanding even more intensely. But like I said, the most interesting thing that I found was that the World Bank actually got involved in the One Health discussion, which seems strange.
Yeah. What are you doing here?
One of these things is not like the other. But it is. The World Bank signed on and said, we're going to do an efficacy and economic examination of One Health. And what they found is that efficiency by combining these agencies and combining this approach greatly increased. The efficiency increased by insane amounts in moderate to low implementation. They found that per year, just in the US, taking a One Health approach saved $184 million, or about 10% of the total costs of environmental, human health, and animal health initiatives.
I would believe that.
It's crazy to me. They also found that if this was implemented at a relatively large scale across agencies, there'd be a $506 million a year savings, or about 15% of total costs spread across these agencies.
Wow.
Would be seen, which is a lot of money.
Yeah. $5 million?
$500 million.
$500 million?
Yes.
Yes, that's a good chunk of change.
Yes. So by implementing a One Health approach, not only are we protecting human health and animal health and environmental health, we're saving money. This seems like a ringer for me.
Yeah.
Like, let's just drop everything and move to a One Health initiative.
Feels like a win-win. Is there like a substantial cost to change over to those sort of practices, I would imagine? Like, why? What's the motivation for people to resist this?
There really isn't one. The only thing that I could imagine taking more time and money is sharing the information you've received, but also just getting to a point where you can share the information you have and knowing what information is valuable and what information isn't valuable when you're conducting your own studies, I think is sort of where it's going to be hard to parse it out. But in general, I think the best thing that can be done is to just be aware. I think that animal scientists need to be aware of what's going on with the environmental health, that the animals that they're researching, what the environmental health is. And also, we need to be mindful of what human health in the area is, but also doctors and medical professionals and people doing medical research need to be knowledgeable about what's going on in the environment that their diseases they're researching on exist in.
Sort of moving away from the right hand doesn't know what the left hand is doing mentality.
Right. So I think it falls a lot on scientists to just be more involved, but also if it's going to be implemented, government agencies also just need to be wary. And I think the steps the CDC and the EPA are taking are a good benchmark that we are moving in that direction.
Great. That's pretty encouraging.
Yeah. So it's not all doom and gloom.
Yeah.
We're starting to understand why these things happen. You're probably not going to die of diarrhea.
That's great news. That's honestly the best thing you've said this whole segment.
Don't drink water from a stream.
Okay.
And you'll be okay in most parts of the U.S.
Okay. All right. Today we're going to talk about something called the Mossbauer Effect.
Is that a name?
It is a name. It's the name of the person who discovered it.
Sounds cool.
Right? The usual usual method for naming things in science, as far as I understand.
Especially with, like, theorems.
Yeah.
Or effects.
Oh, yeah. Yeah.
Always named after a person.
Yeah, I got to quick put my name tag on this.
Yeah.
Yeah, right. So it's named after a guy named Rudolf Mossbauer, who was a physicist. And actually, for discovering this, he won the Nobel Prize.
Go Rudolph.
Right? I know. It gets even better. Like, the implications of this are pretty far-reaching, which is weird that a lot of people don't really know what it is, because it has applications in a lot of different areas in science.
All the more fun to learn about.
I know. It's super cool.
Good topic.
Yeah, I think so, but I'm biased. So in order to understand this concept, there are a few concepts that we have to understand first. These are all going to be building off of what we talked about a little bit on the last episode with frequencies and harmonics and waves and things like that. So the first one is resonance. That occurs when the frequency at which a force is periodically applied is equal or nearly equal to one of the natural frequencies of the system on which it acts. This causes the system to oscillate with larger amplitude than when the force is applied at other frequencies.
It's a lot of information.
It's a mouthful, yeah. Basically what it's saying is that if you have a tone playing at one frequency and you have another tone playing at the same frequency, it's going to be louder than if they were playing at different frequencies.
Okay.
Because they're kind of paired. So the example that I like to use is two trumpets. You have one playing, say, a C, and the other one plays the same C. Because they're the same frequency, presumably, or nearly the same frequency, it's going to be louder. Now, the same thing applies to, if you think of the waves instead of sound, if you think of it as light. The next concept to understand is fluorescence.
My favorite.
I know. Super cool. There's going to be some redundance, by the way, in these because we're just building up to this big wordy concept. That's basically a combination of all of these things. Fluorescence is luminescence or emitting light that is caused by the absorption of radiation at one wavelength, followed by the nearly immediate re-radiation, usually at a different wavelength. So that's a fancy way of saying it's the emission of light by a substance that absorbed light or other radiation.
Would, like, the glow-in-the-dark stars that you have on your ceiling be this?
Yes, exactly. Yep. And we're going to talk a little bit more about stuff like that in a bit here, too. So resonance fluorescence.
Oh, wow.
Yes, I know. I'm just going to keep building, mashing all these words together. So resonance fluorescence is fluorescence in which the light emitted has the same wavelength as the light exciting the emission. So it's similar to those two trumpets. It's just...
two trumpets of light.
That's a horrifying thought. It's like being able to see loudness. So the next concept to understand is gamma rays. So fluorescence can appear in a number of different forms, and the source of that fluorescence comes from light rays. One would be X-rays. There are a couple of other different kinds that don't really apply, and then there's gamma rays. So the difference between gamma rays and X-rays is how they're created. Gamma rays are a penetrating electromagnetic radiation arising from the radioactive decay of atomic nuclei. So they're basically created by nuclear transitions, changes in the nucleus of an atom. X-rays are created by electronic transitions, and they usually have lower energy than gamma rays. So that's something to keep in mind.
This might not be in the same realm, and you might not have the answer, but I do have a question.
Yeah.
Are gamma rays naturally occurring, whereas X-rays are man-made?
No, they're both naturally occurring.
Okay.
It's just, it's harder to... It was previously, before this, harder to identify gamma rays because X-rays could be, that's why, like in medicine, they had X-rays first. And now they have, and we'll get into this, they have machines that they can use. Or if you think of like airport security, they have those new machines that make you look like a really creepy human body in the sensor instead of X-rays that uses gamma rays.
Okay. What is the natural existence of X-rays?
So, what do you mean?
Where would you find X-rays not in a medical lab?
So the difference is how they occur and where they're found. They're both naturally occurring. But like I said, X-rays are created by electronic transitions. So those are generally observed in gases.
I see. Okay.
And we're going to get to where gamma rays are observed in a sec. So to understand the next concept, resonance fluorescence before this experiment was basically only ever observed in X-rays because those are the ones we could see because gases actually emitted some of those rays, the X-rays, and they're just easier to detect. Nuclear resonant fluorescence, more words mashing. It's not over yet.
Oh, no.
I know. We're almost there. Nuclear resonant fluorescence is a nuclear process in which a nucleus absorbs and emits high-energy photons called gamma rays.
Okay.
So it's the same thing. It's resonance fluorescence where the light emitted has the same wavelength as the light that's exciting the emission, but it's instead of with X-rays, it's with gamma rays. That's the big difference here.
So in 1999's The Mummy starring Brendan Fraser.
I don't know how we ended up here, but...
We always do. They go down into the tomb,
mm-hmm.
and Rachel Weisz's character turns a mirror,
mm-hmm.
and the mirror's collect light and then bounce light to other mirrors, and it lights the whole room. Is that sort of a Hollywood version of this effect? Because the light is being reflected back and forth.
That has more to do, maybe. I don't think so. I think that has more to do with reflective surfaces.
All right.
Because I could be wrong about that. We should revisit this one in the corrections. But I think it's just that it doesn't absorb necessarily. It just reflects.
Okay.
This is where the actual atom absorbs the energy and then redistributes it, which is how you get like the glow in the dark. And the nuclear resonant fluorescence, that discovery essentially led to the explanation of how things can glow in the dark, like the glow in the dark toys that collect light and then re-emit it. It's also, like I said before, used for contraband detection. So like in the airport, they used to have the X-ray machines. Now they upgraded to gamma ray machines. Generally speaking, in the nuclear resonant fluorescence, the nucleus recoils during the emission or absorption of a gamma ray. So think of it as shooting a gun. So when the nucleus sends out or distributes a gamma ray, it's like it's shooting a bullet out of the gun. That gun will recoil because of that force. Now, if you have the gun up against the shoulder of the shooter, it's going to recoil less because it butts up against. It has somewhere to distribute that energy. So because of this, gamma ray resonance is only possible in solids, not in gases, because in gases, it doesn't have anywhere to distribute. And there's a reason for that I'll get to in a sec. So we're finally to the Mossbauer effect. When we combine all of those words and concepts, it gives us recoilless nuclear resonance fluorescence.
Dang.
Yeah.
So we're at the end.
Yeah, it's a mouthful. I'm glad they changed it to the Mossbauer effect, so I don't have to say that every time. So the big problem before was that they couldn't observe the gamma rays because the energy to redistribute those rays was being lost. And it was being distributed to the nuclei and not being bounced. There's too much energy wasted in the process. So with the Mossbauer effect, it uses a solid crystal in which the emitting nucleus is bound. So the crystal lattice somehow, I don't know how they do this. It absorbs the recoil rather than the nuclei, and it doesn't waste all that energy. So when this happens, no or almost no gamma energy is lost to the recoil. So it can be observed. It can be bounced back and observed, which is why it only works in a solid crystal and not in a gas, which is crazy, right?
It's insane.
He got a lot of criticism for this because it sounds at the time, apparently it sounded pretty crazy, like you shouldn't be able to do that.
What is the time period for this?
You had to ask. I want to say like the 1950s or 60s or something.
So this is a relatively new phenomenon.
It's fairly new.
Which explains why the early 90s had so much glow-in-the-dark stuff.
Yeah, right. Well, yeah, because I'm sure decades before that, there's no way. Maybe they had it and just didn't understand it. 1958.
Okay.
Looks like. So this is coming on in the time of a lot of those discoveries in physics.
Right.
The main application of this is Mossbauer spectroscopy. Do you know how to say that?
I think it's spectroscopy.
Spectroscopy. Whatever it is, we'll cover it in corrections if I'm wrong.
We don't need to know how to say it.
No, that's the word. Basically what it is it combines this effect with the Doppler effect to monitor interactions between a nucleus and its electrons and those of its neighbors. So it basically studies the characteristics of atoms, which is nuts. If you don't know what the Doppler effect is, It's the change in frequency of a wave in relation to an observer moving relative to the new wave source. So a good example of this, yeah.
I was just going to say it's like an ambulance.
Yeah, exactly. With the sirens on, drives past. You hear it get louder, the frequency gets higher, and then it gets quieter and lower as it drives off. So they use that to pinpoint, I guess, somehow in the process, whatever they're looking for, and that lets them observe the atoms, which is nuts. I mean, this is kind of where it's way over my head.
Well, right, and on such a tiny scale.
Yeah.
Like when you hear the Doppler effect talked about, it's always an ambulance driving past a person,
right,
or
exactly.
a super fast plane flying above a person at high speeds.
Well, because it's sound waves, and those are pretty easy to observe because they're just out there and they're pretty loud and they go into our ear. And the gamma rays are harder to observe for whatever reason. I think it's because of the light spectrum and maybe our eyes can't necessarily detect them, something like that. The impact of this is, like I said, very broad and influential. It was used to prove gravitational redshift. Do you know what that is?
No.
It's a big deal in Einstein's, what's that called?
Theory of relativity?
Thank you. Theory of relativity. That's not right.
No.
It's apparently a big deal. I would say look it up because there's a lot on it. But it was essentially proven to be true. It was initially in the theory, but it was proven to be true through this experiment called the Pound-Rebka experiment, and it used the Mossbauer spectroscopy to identify that and prove it. It also is used in measuring the timeline of nuclear decay. So you can measure a lot of, there's all sorts of uses for that.
Yeah. My mind goes to being able to detect isotopes, like radon isotopes in fossils.
You're talking about like carbon dating?
I'm talking about radon dating.
Is that? Here's where I'm a plebeian. Is it different?
They're very similar. It's just that radon has a much longer half-life than carbon. So carbon dating, I think, can only be used up to about 10,000 years.
Okay.
Before the carbon isotopes are no longer able to be detected, whereas radon has a much longer half-life. And I think it is just in the bones of fossils. I could be making that up. But I know they use it as a way to create timelines for fossils that they find.
I imagine, I don't know if if they're directly related or if this is how they do that, but they're definitely similar processes at least.
Okay.
They can also use it to observe the chemical structure, chemical bonds, valence and covalence, atomic structure. It gave us a lot more insight into the atom.
So it didn't only help us with physical properties, it's also helping with like chemical and microscopic and nuclear properties.
Yeah, it's got applications in chemistry and particle physics and all over the place. And a lot of people haven't heard of it, but it's kind of I don't want to say the quadratic equation of a lot of those sciences, but it is the yardstick for a lot of different things throughout a lot of different disciplines.
Do you know if it relates at all to the study of matter and antimatter?
I would imagine, but I don't know. That might be
something else to revisit.
Yeah, something to come back to. But this is a major building block of those things.
Wow.
Right?
That's crazy.
Isn't it?
I'm so glad we ended on something so interesting and cool and important instead of
something that was such a bummer.
Sorry, everybody.
No offense, Gus. I found it to be an interesting topic. It was
just not quite as interesting as Rudolph Moss.
I think it was Mossbauer.
Mossbauer.
I think it was as interesting. It was just definitely more depressing, too.
Sorry, everybody.
Yeah. That's all I've got. Do you have anything else, Gus?
I don't. Just remember to keep an eye on us on social media. Sometimes we post things that we don't talk about on the podcast. And tell your friends about us.
Yeah.
Please enjoy and make other people enjoy.
Yeah. Make them.
Force them.
By any means necessary.
If you're going to take a 4-hour-long road trip, you can put us on. If you're the passenger and in charge of music and podcasts.
Yep.
We're a great fit for the car.
Yeah. Also 20-minute commutes because we have these segments.
It's perfect for everything.
Yes. Very universal.
As well, give us feedback. Tell us things we're saying wrong. If we have particle physicists in the audience, we would love to hear more about the Mossbauer Effect.
Yeah.
We're also incredibly open to having people on the podcast. We wanted to get our sea legs a little bit before we invited people to join us. But if you have interesting takes on any of these concepts or a concept that you think we should cover, please reach out to us.
Definitely.
Because we would love to have people on.
Yeah, we're going to start doing interviews a little more often in the next section of this season. So look forward to that too.
As always, I'm Kelsey.
And I'm Reese.
And this is Charismatic Megafauna.